Testing, testing, 1, 2, 3. Could somebody please let me know if they can hear me in the chat?
Yes, sir, we can hear you. Or at
Awesome.
least I can.
Appreciate that. All right, so um, I think it's probably about time for us to get started. We might have some more people trickle in. I did send an announcement in the in Canvas to let people know, just in case they'd forgotten. Um, I prefer it if you shout out your questions, stop me, speak over a microphone. There's a push to talk feature. You don't have to unmute yourself fully. Just press the space bar down, and usually that allows you to talk. I hate the chat bubbles that pop up. They're usually like right in front of whatever I'm watching or writing down, and then it's really, really hard for me to keep focus. Way easier for me to actually field your questions if you just call them out. Okay, guys? And if people start throwing stuff in the chat, if somebody could be kind enough to politely let them know also in the chat, hey, don't be doing that. Dr. Ad prefers if you call out the question. Sound good, guys?
Yes, sir.
Fabulous. Okay. Um, let's see. I need to share my screen here. Okay. So, I did prepare a few little things that I think are representative questions from our exam. These are not the exact questions from the exam for obvious reasons, and I didn't include any of the more multiple choice style things that we're going to be seeing just because I didn't want to have to write a whole new set of multiple choice questions, and of course, if you've seen the multiple choice questions once, you probably know the right answer. So I focused on things that were like, more math-based, nomenclature-based for this particular review. Uh, in terms of preparing yourself for the multiple choice sections of the exam, I recommend that you go back through some of the old experiments that were about determining the shape of the atom and what it's made out of and all that stuff. Those might be on the exam. Basic physical and chemical property stuff, like know what a metal is, know what a nonmetal is. I did go over a lot of these things, I think, in the study guide that I posted. So if you just take a look at that, you should be in pretty good shape for anything that isn't explicitly covered in what we talk about here. As I was saying, I did prepare a few questions for us to go over. I'm going to start working these questions. I'll pause for you to ask me stuff in between them, but again, please feel free to shout out as you have any ideas, as you have any thoughts that you want addressed right away. And if you guys have anything in particular that I am not covering here that you want to work on, that you have questions about, you can, again, interrupt me at any moment, and we can just kind of shift gears and start working on your thing. And I'm sorry, I do need to pause for probably another 60 seconds here because I just realized I left my graphing calculator in my work bag. I'll be right back, all right, folks?
All right.
Okay, sorry for the delay. Let's get into it. So for our first one here, we have what is the formula of titanium 2 oxide? What I like to do when I start solving the nomenclature and molecular formula type questions, I prefer to start by figuring out what type of nomenclature we're doing, figure out what rules apply from there. So for this first one, titanium 2 oxide, there's some important clues in here about what type of compound this is that allow us to figure out what rules for nomenclature are going to apply. Titanium and oxide, those are a metal and a nonmetal. We can take a look over at our periodic table here to confirm that. Of course, you might not know what every metal is or every nonmetal, and so you're going to want to take a look at the periodic table provided to you on the exam to confirm. And we find titanium here and oxygen right over here. And so that's going to tell us that this is going to be an ionic compound. Our ionic compounds are always a combination of a metal and a nonmetal. And so what I do with that information is I'm going to look for the chemical symbol that applies to titanium and oxide there. So for titanium, it's just going to be my Ti. Pretend that looks like a capital T for me. Sorry, I'm getting used to this new tablet I have here. And then the oxygen is just going to be an O. Now I keep these a little bit far apart at first because we're not done just by writing down the titanium and the oxygen. We also need to figure out what the proportion of these two elements is with each other. In order to figure out what that proportion is, we need to look at the charge of each of these two things. In general, when you're looking at a compound's name, we assume that it's going to be the neutral compound. And so you have to balance the charge from the metal and the nonmetal. In order to do that, we got to figure out what each of their charges is. So I see here we have titanium 2. That Roman numeral 2 tells us that this is a 2 plus. The way you know that it's a plus is, well, there's a few different ways you can figure it out. In particular, we know that all of the metals are pretty much always going to be pluses, especially for a General Chemistry 1 course. They just prefer to be positively charged. In general, unless you see like a minus in front of the Roman numerals, we're assuming that it's going to be positive as well. And also, the first thing listed in your chemical compound is always going to be the more positive thing. So titanium 2 tells us it's titanium 2 plus. We got a 2 plus. Okay. Now, for the oxygen, we're going to have to take a look at our periodic table to figure out what charge it's going to have. There are several different counting techniques, several rules, and we'll talk about why they work and why they exist later this semester. But I think that the easiest one, especially just for this first test, is you're going to start at the last column, and we assume this is a charge of 0. And then as you move to the left, you're going to decrease the charge by 1. And so helium, neon, argon, all of the noble gases are going to be a 0. This is going to be -1, and then this column's -2 and -3 for the nitrogen column there. So oxygen, being in this -2 column, is going to have a -2 charge. And we're going to write that up top, -2. Okay. Now what we're going to do is a swap. We're going to take the 2 plus from the titanium, the -2 from the oxygen, and we're going to swap our superscripts for subscripts. And this is just like a little trick. It might have talked about it in your textbook, might not have, but it's a really good starting point for figuring out what your chemical formula is going to look like in the end. This, however, is not always the final answer. In particular, we know that anytime you're trying to write down an empirical formula, it's got to be the lowest whole number ratio of those things. All of our ionic compounds are written as empirical formulas, and so the 2's, of course, are both divisible by 2, and you can show this math if you feel like it. It doesn't really matter. I won't be grading that on the exam, and so we can actually write this simply as TiO. Titanium 2 oxide is TiO. Any questions at this point? If you didn't like that trick, that's okay. We'll get a little bit more practice with it later on, and you don't even need to use that. Some of you are probably, more mathematically inclined than the rest of us, and you might be able to simply see, oh, a 2 plus and a 2 minus, they're clearly in a 1-to-1 ratio because those charges balance automatically. And if you see it that way, great, no problem. Just go ahead and write it down the correct way. All right, let's keep on moving. Element Q. Not a real element, for the record, there is no Q on the periodic table, has an atomic number of 55. Consider the isotope Q113. How many neutrons are in a neutral atom of this isotope? Now, hopefully you remember from when we were doing our homework assignments that sometimes there is unnecessary information in these word problems. It's up to you to be able to sort through it and figure out which numbers matter for determining your answer and which ones do not. I see atomic number 55. So atomic numbers, we know, are equal to the number of protons. And so we can pretty much just say right now that we have 55 protons in this thing. We're considering an isotope. Notice that the isotope number is 113. This is larger than the number of protons, roughly by a factor of 2. And that's very typical for atoms, where they'll have more or less twice as large of a mass as they do a number of protons. The reason for that difference is because we also have neutrons as a part of the nucleus. Hopefully you've put together the names, the etymology a little bit by now, and noticed that neutrons are the neutral ones. They don't have any charge associated with them. They're really just there to kind of space out the protons, and they add quite a bit of mass to our nucleus. So, if we're trying to figure out how many neutrons are in a neutral atom of this isotope, we essentially just have to take the isotope mass, 113, and subtract the atomic number. So the isotope mass, 113, minus 55, which is the number of protons, is going to give us something. And yes, I know it's not very complicated math, but it's hard to do math and talk at the same time, so I'm plugging it in the calculator, and we get 58. And that would be our neutrons. Do I have any questions at this point? So the unnecessary information here was that it said it was specifically a neutral atom of this isotope. Would anything have changed if I said it had a +1 charge or a -1 charge?
Yes, if it would have had a -1 charge, that would have, well, no. I was going to say it could have one less proton, but that could also mean that it could have one more electron.
Yes. Good catch. And that's exactly correct, that it could have and would always have one more electron instead. The atomic number does not change under normal circumstances. You can't add a proton and then have the same element. It would no longer be element Q if we added a proton or took away a proton. And so instead, anytime you're talking about charges, it is 100% talking about the number of electrons that an atom has, not the number of protons that it has. And so seeing if it had a minus charge or a plus charge wouldn't actually affect the number of neutrons. Good job. Okay, let's moving right along now. An object with a mass of 2.355 grams is placed inside a graduated cylinder. That's the tall, narrow one from your lab class, has the little marks on it. The volume of water in the graduated cylinder rises from 13.1 milliliters to 15.8 milliliters. Calculate the density of the marble. Whoops, let slip that this is a marble-based problem on the exam. I tried to switch some of the wording around a little bit, but anyway. Let's see here. What information is necessary? You would get a formula sheet on the exam. Sorry, I didn't copy it over here exactly, but the formulas that are on it are pretty basic. It's just things like how to convert Celsius to Fahrenheit, Celsius to Kelvin, and how to figure out what density is. So I'll just write it down here for you. Hopefully you've remembered from your lab classes. So density is equal to the mass divided by the volume. This is just a plug and chug question. We're trying to figure out what the mass is, figure out what the volume is, and that's going to tell us our density. So the mass was already given to us up here, is the 2.355 grams. So I'm going to set the mass equal to, oops, let's see. 2.355 grams over, and we need the volume here. Now it's up to you guys how you want to figure out the volume. Some people would just put it in parentheses here, and they would say the final volume minus the initial volume. Other people might like to solve for it somewhere else. It is important, though, that the volume is always going to be equal to the V final minus the V initial. The reason it has to be final minus initial is because, well, first of all, it's telling us it rises from this to this. And so that tells us that, it now has more volume than it did previously. So the V final would have to go first. And also, negative volume is not possible. Can't be done. Same thing with negative mass. These are not realistic values. In the real world, everything has volume, everything has mass. If it has neither of those things, it doesn't exist, and it certainly can't have a negative quantity of those things. That's for the realm of science fiction. And so if you accidentally put the wrong things in here and you end up with a negative volume, you are incorrect. Go back and check your work. Make sure that you have a positive value for your mass, positive value for density, and of course positive for your volume. So I'm going to take my 15.8, subtract from it my 13.1, and that will give me 2.7 milliliters. And we're going to stick that on the bottom here, 2.7 ml. And then when we solve for that, let's see, it'll be 2.355 divided by 2.7, and I get 0.872222, and that just keeps going for quite a while, probably until infinity. So the question is, given that this is a digital test, we're going to be putting the answers in. How do I know where to truncate this number? Well, what we're doing here is a sig fig calculation now. We have to figure out which of these values matters for determining the sig figs, and then make sure that we truncate or round our final answer based on the correct number of sig figs. We were given a 4 sig fig number here, and we were given 3 sig fig numbers here. Now, you do technically treat addition and subtraction differently. It's about the number of decimal places, not about the number of sig figs. But since these both have one decimal place, our final volume here, or the change in volume, I should say, I'll call this delta V for change in volume, I should have probably included the 0 after this. Even though my calculator didn't show 0 there, I know that this actually has, oh no, it doesn't have that. Okay, sorry. This is just a 2 sig fig number. My mistake. It's the number of decimal places. We kept one decimal place, and so this is the correct number of sig figs. All right. So looking at these two values here, we are going to be dividing them, and so we keep the one with fewer sig figs, which is, of course, the 2.7 here. Knowing that, we have to figure out which one of these values is going to count as a sig fig. Does this first 0 count as a sig fig? Well, there's a pretty easy way to figure that out. You just have to decide, is this number telling us how accurate the number is, or is it telling us how big the number is? Zeros before the decimal point are just telling us that we have a decimal. This is something that is less than 1. It's not telling us how specific that decimal is. The specificity is coming after the decimal point. And so zeros that lead the decimal point do not count as sig figs. For that reason, we're just going to keep the 8 and the 7 as sig figs here. And so our final answer would be 0.87. That is the correct number of sig figs for this problem. Any questions? Okay. Little temperature conversion here. We're looking for Celsius. We are given Fahrenheit. The formula, there's one formula for going forwards, there's one formula for going backwards. They really do mean the exact same thing. Someone's just rearranged them and treated them like two separate formulas. I don't like to do it that way. Let's see here. We're going to say that 134.10 F is equal to 9 fifths for Celsius. Yeah. 9/5 Celsius plus 32. And so the Celsius here is going to be our unknown. What we need to do is subtract 32 from both sides. Oh, geez. Sorry, still getting used to the new tablet. Okay. Nope, still doing it. Okay. So we subtract 32 from both sides. 134.10 minus 32 is going to give me 102.1 Fahrenheit is equal to 9/5 Celsius. We are going to multiply both sides by 5 to get rid of the 5 there. Times 5 times 5. And I'm just showing all the math out here because I know that someone's probably going to benefit from it. If it's easy for you to do this all on your calculator or all in your head, that's fine. I'm not grading your work for solving these questions. So we get 510.5 Fahrenheit equal to 9 Celsius, and then we're going to divide both sides by 9. And we end up with 56.7222, etc. degrees Celsius as our answer. So, how many sig figs do I need to keep here? It's a good question, right? Because I see that there's like the number 32, there's the 9/5, there's the 134.10 degrees Fahrenheit. Which of those is going to be a measured value that we need to apply sig figs to and which is not? Well, because the imperial units are based on their metric cousins, so that's how we've defined all of them, this is an exact value. Everything that's shown here is just part of the conversion factor. So no, we're not treating the plus 32 as if it was 2 sig figs. That's an exact value instead. And what that means is we actually need to keep all 5 sig figs from that measured degrees Fahrenheit. We are treating it like 5 sig figs specifically because this trailing 0 after the decimal point there, that's telling us how sure we are that we got to this number. It's not just 134.1, it's 134.10. We had that little line on our thermometer and we were able to get real close to it, and we say, no, it's exactly on that line. It's not above it, it's not below it at all. And so to turn this number into 5 sig figs, of course, we're just going to be rounding down, and so it becomes 56.722.
Can I ask a question?
Absolutely.
It's in regards to the formula that we used.
Uh-huh.
Would you still get the same answer if you, instead of like doing that formula that you used, that you'd use the opposite formula and just put the 134 minus 32 times 9/5 equals Celsius? Would you still get the
Isn't it
same
times 5 over
answer?
9?
I mean the other, oh, 9/5. Wait,
Did I
I'm
do it
looking at
backwards or
the
did you do it backwards?
I'm looking at the formula on your study guide,
Okay.
and it's like Fahrenheit minus 32 in parentheses times, well, technically you put 95.
Oh, sorry. I just copied and pasted, and so there was probably some formatting there that got funky.
Gotcha.
Thanks
My
for catching
question,
that. I'll take a look.
okay. Yeah, so my question is, would you put the given Fahrenheit into that equation for Celsius and then
It
do
should give you
that?
the exact same thing.
Okay, okay. I was wondering.
Yeah. So all I did was I didn't do the rearrangement. The rearrangement should allow you to see the exact same, or it should give you the exact same answer.
Okay,
Oh yeah, that is all messed up. Okay. Well, that's part of the problem then. So I'll take care of that. Thanks for catching that for me.
no problem.
Okay. Anything else, folks? Awesome. Consider an atom of nitrogen 13. What is in the nucleus of this atom? On your exam, this is less open-ended. I think I put some multiple choice questions in there, but let's just go ahead and figure it out. What's in the nucleus of any atom? Well, the atom is made up of three particles. We have the proton, the neutron, and the electron. And based on our experiments that we learned about how we figured out the subatomic particles and what atoms were made up of, we learned that most of the mass lives in the nucleus. It's all very, very dense, packed down real tight, and everything else of the atom is almost entirely empty space, just filled in by a few very little electrons. And so the nucleus is where it contains our protons and neutrons, and then the mostly empty space around it is just a cloud of electrons. So we're not going to find any electrons if you look in the nucleus. And conversely, you won't find any protons or neutrons if you look in the electron cloud. So we're going to try and figure out how many protons and how many neutrons nitrogen-13 has. To figure it out, they've given us nitrogen-13 here. So the 13 is going to be our mass number that tells us how many protons plus neutrons. But importantly, we don't see the number of protons. We don't see the atomic number listed here. However, you will always have access to a periodic table, and that's just the reference sheet that we need to figure out how many protons our nitrogen has. And so that number 7 there tells us this has 7 protons. And so that's going to allow us to say, all right, so we have 13 protons plus neutrons. I subtract the atomic number of 7, which is actually the number of protons, and that's going to give me 6 protons. And then the rest of it is going to be not protons, neutrons. That is 6 neutrons, because we already knew that the 7 was the number of protons. Any questions?
Yes, sir. I actually do have a question.
Okay.
I mean, this is kind of a little bit it's a simple question. I know, I mean, obviously we use the negative sign and the positive sign. There's also the mathematical plus minus sign. Do we use a specific sign for neutrons like that?
No, they're neutral.
Neutral? Okay. I was just wondering if like the plus over the minus meant like it was neutral or
No,
in
no, no,
between
no.
or something.
That specific symbol is something that's used in statistical analysis, and
Okay.
it means plus or minus, more or less. It
Yeah.
usually is defining a standard deviation, and you'll learn all about that when you get to statistics. It means that we're sure this number is accurate within this margin.
Okay.
Like, it could be this much greater, this much less. We don't use that for neutrons. They don't have a plus and a minus. They have nothing.
It's just not a charge. They're just
It's just not
neutrons.
charged. Yep.
Okay. Thank you.
Yep, no problem. All right, let's express this in scientific notation. I know you guys have probably had scientific notation hammered into your heads from when you were very, very young in school, but we do need to make sure you're able to do it here. So to figure out scientific notation, you're just going to start at the decimal point and move a certain number of spaces over until you get to just before the end of the number. And then if you're moving forwards, so from, I should say right to left, you're going to be getting a positive exponent, and if you move from left to right, you're going to get a negative exponent. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I have to write all of the significant numbers inside my scientific notation. To figure out which ones are significant, we have to remember our rules for the zeros. Our captive zeros, that is zeros in between two non-zero digits, those count. Those are significant. But trailing zeros before a decimal point do not count, because those are just telling us how large the number is. They're not telling us how specific the number is. And so I'm going to write down 1.001001. And then because we're doing it on pen and paper, we write times 10 to the, and I think I said 9, right? 1, Yes, times 10 to the ninth. So that would be this number in scientific notation. On your exam, you're going to use the exact same format for inputting the scientific notation as you have been in lumen ohm. And so this number would be 1.001001 E9. What is the IUPAC name for HNO2? IUPAC is an acronym that stands for the International Union of Pure and Applied Chemistry. It's a bunch of old dudes with, I assume, really, really long beards. They sit around a giant conference table in France once every 10 years, and they argue about how we should talk about chemistry. I'm sure it's just a blast. I hope to someday be chosen for the committee. Uh, but really, though, these are very useful rules. They give us a systematic way to speak about chemistry with each other. Certainly, you don't want two things to describe the exact same chemical compound because that could become really, really messy. So, if you see IUPAC, it just means name this thing. Now, HNO2. We're trying to figure out, first of all, what type of compound this is. I like to break up nomenclature into three different chemical classes. We have our ionic compounds, we have our covalent compounds, and we have our acids. Determining whether something is an acid or not is actually really straightforward. You just have to see, does it start with the letter H? At least for the purposes of our class, that's always how it's going to work out. This compound starts with an H. I'm going to name this as an acid for that reason. So, what type of acid? Well, we have two types of acid. We have the binary acids, and we have the oxyacids, or sometimes they're called the polyatomic acids. Binary acids are always made of exactly two elements. So it's going to be hydrogen and one other thing. Looking at this compound, I see that we have three elements. I see a hydrogen, I see a nitrogen, and I see an oxygen. Remember, every capital letter is the beginning of a new element. So, since we have three elements here, it must be one of the oxyacids or polyatomic acids. To figure out how we name this, we need to first understand what the name of NO2 is. To do that, I'm going to look at a polyatomic ion table. Now, this is the exact polyatomic ion table that I've provided for you on the exam. So we're going to look for an NO2 on this list. And as I'm scrolling through, I see, NO2 right around here. So that NO2 is called nitrite. Moving back over here, it's helpful to write it down. So NO2 minus is equal to nitrite. In order to convert the polyatomic ion name into the acid name, you just have to remember that 8 becomes ic acid and ite becomes us acid. And so we're just going to be swapping those suffixes, and that's all you have to do. Looking at this name, we have nitrite, so the ite goes away, and it's going to become nitrous acid. Very important to remember that when naming the oxyacids, you do not talk about the hydrogen. Hydrogen is implied. If you mention the hydrogen, you are doing the nomenclature rules for binary acids. This is how we differentiate the two. Where the binary acids, you talk about the hydro, and the oxyacids, you don't. And so please don't make that mistake. Only use hydro if it's a binary acid. Any questions here?
Yes. Outside of the exam, can you send out that page with the
Oh,
polyatomic
yeah,
acids?
sure.
I have had such a hard time finding like a good chart that's royalty free that I don't have to pay like $2 for off of a website.
Really?
Yeah,
That's funny.
yeah.
Okay, I've never seen anybody try and charge for basic chemistry information. But yeah, I will
Be
send that one out.
surprised.
I am shocked as a chemist who has been doing this for a while. I've literally never seen that, but the
Yeah.
internet gets worse and worse every day. So yes, I will send that out to the class. Okay. Anything else?
Wait, I have a question.
Yeah,
So you said for polyatomic acids, we don't talk about the hydrogen?
that's correct.
Okay, thank you.
Yeah, no problem. Tell you what, let's do a binary acid just to make sure that we all understand what's going on there. Let's see here. I have some extra room down here. Okay, so for a binary acid, we talk about hydrogen. So let's say we have HCl. Here, I have the hydrogen. I have a chlorine. You're going to drop the IDE suffix. The "ide" goes away and it becomes ic acid. And you have to mention the hydro here. And so this is going to become hydrochloric acid. Or we could try another one. Let's do H2SE. So Se is for selenium. You would make it selenide in this case. So Se is selenide. And then we get rid of that in favor of ic acid. And because we have the hydrogen here, we just have to say hydro. And so this whole thing becomes hydroselenic acid. Any other questions? All right. Every day you drive to and from work. If you work 20 days a month and work is 18.3 miles from home each way, that's annoying. How long are you spending in gas each month if the cost of gas is $3.20 per gallon and your car gets 25.1 miles per gallon? So this is a little bit of an arithmetic problem, but really it's meant to help us practice dimensional analysis. So we're going to be setting up our dimensional analysis style problem in order to easily convert between all of these different units. So I like to first collect all of my conversion factors and do all of the simple arithmetic early on so that when I set up my dimensional analysis problem, I pretty much am just picking from all of the different conversion factors and then canceling one unit every step of the way. It's kind of a really simple brain-dead way of solving these things, and that's the way I like it. Don't think too hard. Don't do extra work if you don't have to. Just solve it and move on. So I see that we have 18.3 miles from home each way, and so you can't get to work without coming back from work. We're going to have to double this value. So I'll take my 18.3 times 2, and that's going to give me 36.6. So that's how many miles I'm traveling. We're looking for how much I spend in gas. If the cost of gas is $3.20 per gallon, so we'll say we also have $3.20 dollars. I'll just write it as a unit over here so that it looks like all of our other units, dollars per 1 gallon. That's a good conversion factor for us to have. I see also we have 25.1 miles per gallon. Of course, anything that's expressed as a ratio or a fraction, that's going to be a conversion factor for us. We'll have 25.1 mi per 1 gallon. Okay. Are there any other conversion factors I'm missing here?
The 20 days in a month.
There you go. Yeah, it's 20 days. I said 20 days a month, but really that's 20 days per month, right? And so that can also be expressed as a conversion factor. Good catch. 20 days per 1 month. All right, and we're looking for how much we spend per month, right? How much we're spending in gas each month per month if we get these values here. Okay, I think that we have everything we need. Let's just go ahead and set it up. I like to write this out in one great big long line. I think it's easier to cancel your units that way and you miss less information. If you're ever confused, if you don't know where to start, look for anything that has just a single unit in it. That's usually a good starting point. Because of the way that the rules for multiplication and division work, it doesn't actually matter what value you put first. You could technically put 36.6 miles in the middle of the problem or at the end of the problem, but it just makes more sense if it goes first, in my opinion. It seems like students mess up less that way. So we'll put that lone number first, 36.6 mi for miles. Now what we want to do is cancel this unit. You should be canceling a unit every step of the way. So I see miles there, and I'm looking for a value. Here we go, 25.1 miles per 1 gallon. You can just swap these two values. This being a conversion factor is the same as saying this thing, the 25.1 miles per 1 gallon, is equal to 1 over 1. It's an equality. It's the same thing as each other, and for that reason, you can easily flip it to cancel our miles, and that's a totally legal operation. So we're going to go 1 gallon on top, and we'll have the 25.1 miles on the bottom. And so my miles will cancel with my miles. I recommend you do it as you go through because that tells you, okay, I got gallons now. How do I cancel gallons? I'm looking for gallons in my conversion factors here, and I've found it right there. I already have gallons on the bottom here. You need something in the denominator and then the numerator in order to get them to cancel. I said that backwards, numerator, denominator. $3.20 per 1 gallon. So gallons cancels with gallons. Now I have a number of dollars. Okay. And let's see here. What am I missing? Oh, you know what? 36.6 should have been miles per day. Sorry. I realized my error here because I was looking for a way to use this days value there. It wasn't presented anywhere else. And so it's this many miles from home per day. Okay. So we'll put that as per day. And good news, it doesn't change anything yet because we can still put this per 1 day. And so now we know how many dollars per day we're making here. And we're trying to figure out the price of gas per month. And so I want to make days cancel. In order to do that, I'll use this value, the 20 days per 1 month. So 20 days per 1 month. And so days will cancel with days. Now, in order to decide if we're finished or not, we're going to check what units we have left in this equation and check it against what our word problem is asking for. We're looking for how much we are spending, so how much money in gas per month. Spending per month, dollars per month. And I see we have dollars on top, months on bottom. And so when I put this in my calculator, I should get the correct value because my units match. I'm just going to go ahead and plug this in. For those of you that aren't familiar with using the TI-80 whatever, I don't know what number they're on these days, you can just enter these all as one great big long string, and it will take care of the multiplication and division order of operations for you. So I'm just typing it in as 36.6 divided by, because 25.1 is on the bottom, so that's a division, divided by 25.1. And then times 3.20 because that's on the top, and then times 20 because that's on the top. And so I get 93.3227, etc. And we need to figure out how many sig figs we use. Any thoughts? Well, really the debate is between whether we use 2 sig figs for 20 or whether we use the 3 sig figs from everything else. I would make the argument that 20 days a month is an exact value. As much as I'd like to work a half day one of those days, my boss probably expects me to be there 20 days. And so we're going to assume that the days you work is an exact value, in which case we'll round this to 3 sig figs, making this $93.3 per 1 month. Any questions? Sig fig practice. I'd like you guys to chime in with me here. I'm just going to throw some numbers out, and we're going to say how many sig figs they have. Sound like fun? Yeah, that's what I thought. Okay, here we go. How many sig figs?
3.
Yes, good job. Because these leading zeros do not count. They're just telling you how little the number is. But this trailing zero does count because it is telling you that you are really, really sure of where the 1 and the 5 are. Like that measured right on top of the line. You're exactly sure that there is nothing in that position. So 3 sig figs, very good. Let me get somebody else for this next one. How many sig figs? I believe in you, Anna. You can do it.
Um, Wait, so trailing zeros count?
It depends when. If it's trailing zeros after a decimal, they do count. Trailing zeros
Oh, okay.
before the decimal, that's a different situation because that's just telling us how big the number is. It's not telling us how sure we are.
So there's 2.
I would say 2 as well. Yeah, great job. The way I always like to reference this is with something a little bit dark. I remember back during the Deepwater Horizon oil spill, y'all were probably just children when this was going on. I was in college, and I remember the newscaster saying that it was like 22,000 barrels of oil were spilling per day. And I remember thinking to myself, 22,000, 22,000. How on earth are they sure that it's 22,000 barrels? Well, it turns out they're not sure. That was an estimate, right? If they were sure, they would have said 22,000.01 thousand barrels per day, right? If you have the decimal point there, that's telling us, okay, we're really sure this is exactly how many barrels of oil are spilling per day. But that was not the situation. In fact, they had no idea how much water BP was dumping into the Gulf of Mexico Gulf of America. They had no idea how much was being dumped into the Gulf, and so they just rounded to something that seemed reasonable to them, 22,000. And so if it's just zeros before the decimal point, they don't count. They're not significant. If it's zeros after the decimal point, like if I ran, let's say, 5 miles versus if I ran 5.000 miles, you might say, hey, good job, Dr. Ayad, you ran 5 miles. But if I told you I ran 5.000 miles, you'd say, wow, Dr. Ayad, that's a weirdly specific number of miles you ran. Are you okay? Make sense? That's the way I think about it anyway.
Sense.
Yeah, good. Okay. Anybody want more sig fig practice? I feel like those are the tricky parts.
Maybe we could do like 1 or 2 more.
1 or 2 more, you got it, man. Let's see here. We'll do 1.505 times 0.00190 and tell me how many sig figs this answer should have.
4.
Any dissenting opinions?
3.
Oh, would it be 3?
I would also say 3, yeah, because let's take a look here. So you're right that this one has 1, 2, 3, 4 sig figs, right? This one, we're not counting these guys. Those are non-significant. We have 1, 2, 3, because this trailing 0 comes after the decimal point, right? This is the weirdly specific value. And so because of that, we're going to say that this has 3 sig figs, and you keep the lower number of sig figs, not the greater one. So whatever this number is, you should have 3 sig figs. Let's do another. We'll do 1, 0, 0, 1 divided by 13.350. How many sig figs should this value have?
4.
4 as well, yeah, because this one has 5 sig figs, this one has 1, 2, 3, 4 sig figs, and we're going to keep the lower number. Okay, and we are down to the last one that I had prepared for us. What is the IUPAC name for CCl4? In order to solve this one, again, we have to figure out what class of compound this is, and of course it wouldn't be a good review if I didn't leave the last class of compounds for last. So this is going to be a covalent or molecular compound. They are two words that mean the same thing. In essence, the bonding that happens between nonmetals is different than the bonding that happens between metals and nonmetals, and so it gets its own type of name. The reason it needs its own type of name is because you can have lots of different quantities of these different elements combined together. And so you could have CCl4, you might also be able to have something like CCl3, CCl2, and it just changes the number of those elements that are attached to each other. In order to specify how many we have, we use the Greek prefixes. We have to specify using mono, di, tri, tetra, penta, hexa, how many of each of these particular elements are on the molecule. So we should probably figure out what these two elements are first. Head on over to our handy-dandy periodic table. We find carbon right here, and then we find chlorine right there, C and Cl. So we're going to call this carbon. And then I know that I need a prefix in front of the chloride there. For 4, this is probably the only prefix you all didn't know already.
Tetra?
It is, very good. 4 equals tetra. I'd say that this is probably the one that students mess up the most. We know tri from triangle, mono from 1, we know di, we know penta from pentagram or pentagon, hexa from hexagon. Like, these are all names that we are familiar with, but no one talks about tetragons, right? Tetra just means 4 in Greek. And so carbon, tetra, chlor, and remember, we're going to swap the suffix just like we did with the ionic compounds. This is carbon tetrachloride. Notice I didn't use mono, and it's because you shouldn't use mono if there's only one of the first element. If there are multiples of the first element, you do have to specify whether it's 2 or 3 or however many. And if there's only one of the second element, that's when you use mono. For example, CO would be carbon monoxide. Any questions?
Yes.
Okay.
I thought for some reason Ide was only for bonds between metals and nonmetals. I thought that it was going to be carbon tetrachlorate, but is 8 also only for acids?
The 8 suffix is only for polyatomic ions.
Okay, okay.
And we do use "ide" for pretty much just the end of any chemical compound.
Okay.
Unless it has one of the others, like "ite" or "ate" or "ick" or "us, then "ide" is how you end a chemical compound name.
Okay, I see.
Good question. Anything else, guys? Okay. Any other problems that you all want to work on before we head out? Anything that you had from the homework? Anything? Questions about the test formatting?
Will the test questions look just like these?
Pretty similar, yeah. I think it's white on a black background instead of what I have here, but otherwise, yes, they are going to be very, very similar. Um, I got to tell you, I like to put forth minimal effort whenever possible. I copied a lot of these directly from the exam and then changed some numbers. So they're going to look really freaking familiar to you.
Just enough to drive us insane trying to figure out the question.
I sure hope not. I really hope that you don't try and memorize these because then you will get the answer wrong. But
May
yeah,
I ask how many? Oh, sorry.
no, please continue.
I was gonna ask, do you know like around how many questions will be on the exam?
I find that students always ask this, and it's rarely helpful to know. Um, it's 25, but 25
Okay.
what, right? Like if it's 25, how many sig figs, then that's going to take you like 10 minutes to do. If it's 25 of this monster, then you're going to really suffer. Um, so I like to think that the exam is doable within the 1 hour time frame. Very rarely do I have students complain about not being able to finish the first exam. You are going to have some questions that are like the multiple choice style that aren't shown here that are just going to be obvious to you. Like immediately you're going to know it or you're not going to know it, and you should only spend a minute on that question and then move on. And then others, of course, like the nomenclature, like the dimensional analysis stuff here, it's going to take a little bit more time for you to do. And so maybe commit, like 3 to 5 minutes on these. I definitely would caution you, don't spend like 15 minutes on anything. If you really are struggling at that point, it's like 10 minutes, 15 minutes are going by, move on, do the rest of the test, come back and finish it later. Being aware of your time is really, really important in your college level STEM classes. I've seen students just get like hyper fixated on one question. They're like, "Oh, I'm so close. I'm so close. I know I can do it." And then the time expires and they left half the test blank. So please don't let that happen to you.
Okay, thank you.
Yeah.
Also, I've never taken an honor log exam before. So, do you'll provide the periodic table for us? Like we can't use our own.
That's correct. Yes. I
Okay.
specified in the settings for HonorLock. So it's a third party service where they're going to review your webcam, and they probably use some AI detection thing coupled with like an overseas, tech support group to monitor the tests. And they're going to look for things like, oh, you're scrolling on your smartwatch. And they're going to look for things like, oh, that looks like a computer and a friend in the background feeding you answers. And so if you hold up a piece of paper that has a bunch of stuff written on it, it's going to flag the test, and someone's going to pop into your window and he's going to say, "Hey, it looks like you have a periodic table there. You're not supposed to have that. Please put it away." You are going to get one that looks pretty much exactly like this one right here in a link that you will be able to click on. It'll be listed at the top of your exam, and so when you get into the exam, you'll just open it up and it will be this and it will be this, and it's one other piece of paper. I forget which one I included. I guess probably a reference sheet. Um, and those are all allowed on the exam, and that's it. It'll lock down your browser from everything else, so make sure you close all your other programs and stuff, or it's going to flag you as having other stuff open.
Okay, but and we can have our physical calculator
Yes, I did
with us.
specify that you're
Okay.
allowed to use a TI-80, whatever you have. I'm sure that some of
Okay.
the new TI-80 whatevers also have like periodic tables and all kinds of fancy features on them, and I really can't control for that, and I'd really prefer it if you use the periodic table that's on the test. It's not that hard, guys. Um, so yeah, please try not to cheat.
Thank you.
Yeah, of course. Good questions.
To like have a piece of paper next to you to
Yes,
like look up
scratch
problems.
paper is allowed on the exam. You can have as many pieces of scratch paper as you want. Um, I did have somebody ask me in an email. I don't think I had a chance to respond yet. If you're in the room, hi. Uh, you don't need to do the show your work stuff on the exam. I'm not doing partial credit for shown work on this test. In future exams, I will, but not this time around since so much of it is just true or false multiple choice style questions. So you don't have to like draw anything on your tests. The scratch paper is just for you.
Okay, thank you.
Yeah. Any other questions? Well, if not, I want to thank you guys so much for showing up to this. It's much more fun talking to an audience than it is talking to myself here. And so, I really appreciate you keeping me company while I made this video for the rest of the class. Good luck studying. I've got office hours on Thursday from 5 to 6, and otherwise, please shoot me emails with your questions. I'll do my best to answer them as quickly as I can. And yeah, have a great rest of your week. All right, guys?
Thank
Thank
you.
you. Bye
Thank you,
bye.
sir.
Yep, take care, guys.
Good night.
Have a good night.